This is a video on calculating chi-squared value for the test of independence. This is on my website. There are multiple videos on here for you to click on if you're interested in. What this section deals with is testing for independence. Are two variables independent or dependent of each other? And then you can kind of read through this. What we're going to do is we're going to calculate some values with the observed, which you went out and found your data, and we're going to calculate the expected values. So here's some vocabulary for you. One of the things you need to have is your null hypothesis. That's what we call the HO. This is the hypothesis test. If it's successful, the factors are considered independent of each other. If not, we accept the alternative hypothesis, H sub 1, that this H0, the null hypothesis, is rejected, and it implies that there's some kind of connection between the two variables. The next piece is what we call chi-squared. You'll see it written with an x squared or chi squared. It's a test used to see if there's a difference between the observed and the expected values. So there's a formula here. It looks pretty scary looking, but we're going to do it in a chart instead. The observed values, when you go out and collect your data, that's your raw data, and we're going to organize them. Then there's an expected value to see if these two are independent or dependent. Then there's a thing called the significance level. A lot of times we go with a 5% significance level. We'll talk about that later. Critical value, we'll show you in a graph, and then degree of freedom is with a formula. So just some quick things here for you. All right, there's that formula we talked about. So here's our example. Are people over the age of 21 more likely to pass their driving test the first time, is our question. We're going to figure it out. So let's go and pretend we went and surveyed 60 total people. And here is our data. These are what we call the observed values. So we took the survey, and what this first box represents is the people over 21 that passed the test. There was 36 people in that group. Then there were 12 people under 21 that passed, giving you a total of 48. Then 4 people over 21 failed it, and 8 people under 21 failed it, to a total of 12. Your total sample space is 60. So our question is it purely by chance, or is there some connection between driving the driving test and your age? So we're going to calculate the expected values, and this is the equation you need to know. You take the row total times the column total over your sample space. And then this is just in kind of the box, a plain box. So we had 48 people. Here's the row total. We're going to take this number 48 times this number 40, row total and column total, and multiply them together. So 48 and 40. And then you divide it every time by your sample space. And then down here is that number 32. Then you go again. Row total of 48, column total of 20. 48 and 20 divided by 60, and now we're at 16. And then you do that for the 2 more boxes. These 4 numbers that are in the purple are what we're going to use later. They're called your expected values. the calculation of chi-squared comes from. You see it sometimes like this in the formula, or like that. They're the same thing. What we're going to do is set up what we call a contingency table. This first box is all of the observed. So when you went out and took your data, there was 36 people, 12 people, 4 people, and 8 people in those 4 categories. Oops. So where these 4 numbers come from are in the red right here. 36, 12, 4, and 8. Then we went out and calculated the expected. So this is what we call the contingency table. So these are your observed, and then the next column is your expected. When you were taking your rows and your columns, multiply them together and divide it by the sample space. And now here's how you get to calculate chi-squared. The next column is taking the observed minus the expected. So 36 minus 32 is 4. Then take that number and square it, and you get 16. And then you take that number and divide it by the expected, and you get 0.5. And you do that for the next 3 rows. So 12 minus 16 is -4. Square it is 16. 16 minus the expected of 16 is 1. And then next row, 4 minus 8 is -4. Square it is 16. 16 over the expected is 8, and you get 2. Last one, 8 minus 4 is 4. Square it, you get 16. 16 minus 4 is 4. And then you'd add up this last column, 0.5, 1, 2, and 4, and you get 7.5. This is what we call the chi-squared value, 7.5, which we're going to work on next. And then it says, we will explain in the next section what this chi-squared value does. So I'm going to stop the recording.